Hello children, this is our last maths lesson of this week. So far we've been practicing addition and subtraction using formal column methods. Today we're going to use estimating to help us to check our calculations. So we're going to start with some rounding to estimate. So I've got a calculation here, it's 79,574 and I'm taking away 12,476. How would you round those numbers to help you to estimate the answer to the calculation? Well, if we use rounding, 79,000 is rounded up to 80,000 and 12,476 would round down to 12,000. And so my answer would be 68,000 when I'm rounding my calculation. And perhaps you might want to just try that calculation now as a formal written method and see how close I got to my rounding. Pause the video and have a go. Okay, so we're going to use rounding to help us with these calculations. Rosie is working out 2,937 add 1,870. Rosie rounds each number to the nearest 1,000 to estimate the answer. Complete the sentences. 2,937 rounded to the nearest 1,000 is 1,870 rounded to the nearest 1,000 is, and then use your rounded answers to estimate the answer and then calculate the actual answer to this calculation here. Pause the video because that's quite a lot to do and start again when you're ready. Everybody can try this. Okay, so 2,937 rounded to the nearest 1,000 is 3,000. 1,870 rounded to the nearest 1,000 is 2,000. 3,000 add 2,000 is 5,000. So the estimated answer to that calculation is 5,000. And here is the actual calculation. So the actual answer is 4,807. But actually, if I round that to the nearest 1,000, it rounds to 5,000. Good. So you're going to have a little practice on your own now. You're going to round each number to the nearest 10,000. Estimate the answer to the calculations. Pause the video and give it a try. Start the video when you're ready. Okay, so 12,000 rounds to 10,000, 29,580 rounds to 30,000. So the estimated answer is 40,000. And for B, 47,640 rounds to 50,000, 9,485 rounds to 10,000, and 50,000 take away 10,000 is 40,000. Well done if you got that. Now we're going to do the same again. Sometimes we call it approximations when we're rounding. So I want you to round each of these amounts to use it to help you to check your answer. So try the calculation, then use rounding to check your answer. Pause the video, think carefully about the place value when you're doing your formal calculations. Start the video when you're ready. Okay, so A, the answer was 10,851. B, 10,491. C, 70,066. And D, 9,811. I wonder if anybody needed to recheck their calculation after they'd used rounding and approximation to help them to check whether it was right. If anybody went back and had to fix their calculation. Okay, so here we've got a table showing the number of people of different ages living in 3 towns, Town A, Town B and Town C. And this row tells us How many people live in each of those towns under 16 years of age? How many 16 to 65-year-olds live in the town? And how many over 65s live in the town? So this is the population of town A, the population of town B, and the population of town C. Estimate which town has got the greatest population. So you don't have to calculate, use your rounding to help you to estimate which town has got the greatest population. Pause the video and give it a try. Okay, let's have a look. It's town A that's got the greatest population. Town A. Now, we're going to look at these calculations, but we're not going to actually do them. We're going to look at them carefully. So let's look at this first one. Are these statements correct? So without doing any calculations, can we say for certain that 29,999 take away 9,999 will give us the same answer as 30,000 take away 10,000? That's the question. And the same for this one. So is this calculation for sure going to be bigger than this calculation? And then we've got this balance here. We've got this calculation here. Now look carefully because you'll notice that there's something the same in this pattern of these three numbers. There's something the same. And then on this side here, there's something the same. So are these two equal in value? Now we're not going to use our calculation to work them out, we're going to use our estimation to work them out. So pause the video and have a think about it. Look for what's the same. Let's have a look at what the answers are telling us. Okay, so it says that A is true because each number is only one more, so the difference doesn't change. So the difference between these two numbers stays the same because this number here is only one more than this one, and this number here is only one more than this one, but they're both one more. So they are equal in value. Let's try the next one. Now, it says here that this is true, that this side is worth more than this side, is bigger than this side, because you can simply cross these two out because they're the same. So we don't need to look at them. And we can just say that yes, 10,570 is greater than 9,985. Now let's just have a quick look at the last one. It's a similar pattern really. These two numbers are the same and we've added it on and taken it off. So actually we can just remove them because we've added on and taken off the same amount. So we've done the same here. We've added on and taken off the same amount. And so what we're actually saying is this number the same as this number? The same as? And yes, it is. Both sides have got a total of 7,575,980. A bit of reasoning for you there, wasn't there? Okay. So Mo's made a mistake with his calculation. Can you use rounding and approximating to show how you know? So we're not going to look at the calculation, we're just going to use rounding to see if we can work out where she's made her mistake. How do we know she's made a mistake? So I've got 17,000 take away 8,000. 17,000 take away 8,000. 17,000 take away 8,000 is 9,000. And Mo's answer is 18,000, so it's too big. So approximation helped us to work out that Mo's answer was just too big. Dr. Khan writes this question, Mr. Khan writes this question on the board. Dexter's estimate is 7,000 take away 1,000 is 6,000 from this calculation. 7,000 take away 1,000 is 6,000. Whitney's estimate is 7,400 take away 7,000 is 6,700. Whose estimate do you agree with? And explain why. And then can you work out the actual answer to the calculation and see whose estimate was the closest? You can pause the video and have a go. Okay, so whose estimates do you agree with? Well, actually, they're both right because they've just estimated in different ways. So Dexter has rounded to the nearest 1,000 and Whitney has rounded to the nearest 100. So they've done the same amount of rounding, just in a different way. The actual answer, when we worked it out, the closest person was Whitney, and that will be because she has rounded to the nearest 100 rather than rounded to the nearest 1,000. So because she's rounded to a smaller amount, her estimate is closer to the answer. Well, we've worked hard on estimating and approximating today, and I'm hoping that you can see that if we do that, it's a quick way of checking the accuracy of our actual calculations. Next week, I believe that Mrs. Callahan is going to do some work on fractions.